Hello everyone. In this video, I will talk about the divide and conquer algorithms. Divide and conquer is a way of designing an algorithm, or it is just another category of algorithms. In divide and conquer algorithms, we will solve the problems recursively by applying three steps at each level of the recursion. As the first step, we divide the problem into a number of subproblems that are smaller instances of the original problem. After that, we conquer the subproblems by solving them recursively, and if the subproblem size is small enough, we solve it in a straightforward manner. Then finally, we combine the solutions to the subproblem in order to obtain the solution for the original problem. Okay. Oftentimes, the step number 2 and the step number 3 will be collectively called as the conquer step. Now we will look at an example where we will apply this divide and conquer algorithm, so you will get a better idea of the design approach. Imagine that I need to sort an array of numbers. Let's say the numbers are 31, 7, 22, 6, 11, 5, 8, 4. We already know several methods to sort an array of elements, such as the bubble sort or the insertion sort or a selection sort. And there is another sorting algorithm called as the merge sort. Okay. Merge sort actually use the divide and conquer approach. So as the first step, let me write these numbers into these cells. It is 31, 7, 22, 6, 11, 5, 8, 4. So this is an array of 8 numbers. So let me write the index as well, 0, 1. So in total we have 8 numbers. Alright, we will be dividing this array into two halves. We will call the first one as left subarray and the second one as the right subarray. So the left subarray is 31, 7, 22, 6 and 11, 5, 8, 4. So actually we have divided the bigger problem into a smaller problem. Our original problem is to sort this big array of 8 numbers. So what we have done is we divided that into two subproblems. One comprises of the first 4 elements and the second one comprises of the last 4 elements. So this is the left subarray and this is the right subarray. Now I will be dividing this subarray again into two halves. So again I will have 31, 7 as the left subarray of this one, then 22, 6 as the right subarray of this bigger array. Then for the second half I will have 11 and 5 as the left subarray. Then I will have 8 and 4 as the right subarray. Okay. Then I will be dividing this again. So I will have 31, then 7, 22, then 6, 11, 5, 8 and 4. Now we will not be able to divide these arrays into smaller arrays further, so we will stop at this point. So our divide part is over. Now what we have to do is we have to conquer. So what we will do is we will be sorting each of these elements one by one, then we will combine the solutions to get the final sorted array. If you want to sort an array which contains only one element, that is 31, then this array itself is sorted, then that applies for all of these elements. Okay. In the next step, we will be combining the solutions for these two subproblems to get the solution for the higher problem. So which means that if you combine 31 and 7, you have to keep the sorting order. So first I will be writing 7, then I will be writing 31. So this is actually where the combine step or the conquer step happens. Now if you want to combine these two subarrays, then I will be writing 6 first, then 22 next. Then for this one I will be writing 5 first, then 11. Then for these two subarrays I will be writing 4 first, then 8. So we have conquered the sorting of this subarray by merging these two elements. So that is 7 comes first, then 31 next, and that applies for all the smaller arrays written over here. And in the next step I will be merging these two. So I will be writing 6 first, then 7, then I will be writing 22, then I will be writing 31. For the right part, I will be first writing 4, because if you combine these two subarrays, then 4 should come first if it is sorted. So I'm writing 4 first, then 5, then 8 and then 11. Now I will have to combine the solution of these two subproblems to get the solution of the original problem. So I will be writing it over here. Among these two arrays, the smallest one is 4, then the next one is 5, then next one is 6, then 7, then 8, then 11, then 22, then 31. So this is how we sort an array using the merge sort algorithm. So what you have to understand is we have a bigger problem where we have to sort this bigger array. So we divided it into two different halves, into the left subarray and to the right subarray, and we applied into the smallest case as possible. In this base case, we are unable to divide these smaller arrays any further. So we have done the dividing step. Now we have to do the conquer step. The conquer step is actually by combining the solution of two different subproblems. At that time we will keep the smaller number first, then the larger number as the next number in order to solve the smaller subarrays, in order to get the smaller sorted subarray. And we will continue this until we will get the solution for the bigger problem or the original problem. Alright. Now let's look at how this merging is done. So in order to do the merging process, I have a left subarray and the right subarray. Then I have the original array where we will be storing the merged result of the left and right subarrays. To do that, I will be keeping variables I, j, k, where I is keeping the current index of the left subarray, j is keeping the current index of the second subarray or the right subarray, and k is keeping the current index of the merged array. So we will be assigning L is equal to the length of left subarray, R is equal to length of the right subarray. So L will be 4 and small letter r will also be 4. In this while loop, we will check whether the indices of I and j are below 4 and 4, and if it is true, then we will be running these if-else conditions. In the first step, we will be checking whether the first element of the left subarray is less than the right subarray. If it is true, then I will be copying the first element of the left subarray into the final array. Otherwise, I will copy the right subarray's first element to the final array. And if I am copying the content from the left subarray, I will increment the value of I as well as k. And if I am copying from the right subarray, I will be incrementing the value of j as well as the index of the final array A. Now let's run this algorithm to understand this better. To begin with, the value of I is 0, j is 0 and k is 0. So first we will compare whether the left subarray element is less than or equal to the right subarray element. So if you compare the value of 6 is less than or equal to 4, that is we are comparing L of 0 and R of 0. So this condition is not true. So what will happen is this will not enter into this part, it will be executing the else part. So what we will do is we will assign A of k equal to R of j. So R of j is 4 and that will be going to A of k. So j is 0, k is 0, so we will be referring to the first element. So A of 0 will get R of 0, that is 4 will come over here. Now we have to increment the value of k as well as j. So I am moving the value of k and j. So j will be coming over here to 1. Similarly, k will be also coming over to here. In the next step, we will do this procedure again. So let me clear this off. Now we will compare whether L of I is less than or equal to R of j. L of I is 6, R of j is 5. So it is not true. So I need to copy this element 5 to the A of k. So I will copy this 5 to this position. So as we have copied from the right subarray, I have to increment j, and as I have filled one more position in the array A, I need to increment the value of k as well. Therefore, I am taking this j to the next position. Similarly, the value of k to the next position, or k is incremented. Now we will be checking L of I with R of j. So we are comparing 6 and 8. Indeed, 6 is less than or equal to 8. So what we will do is we will execute this part. That is, the L of I will be copied to A of k. So 6 will be copied to A of 2, which is L of 0. Now I need to increment the value of I as well as k. So I am copying I. So I am incrementing I to 1 and I am incrementing k to 3. Okay. Now in the next step, I am comparing 7 and 8. Of course, 7 is less than 8. So I need to copy this element to the array A. So 7 will be copied to this position. Now I need to increment the value of I as well as k. So I is incremented, k is incremented. Next we will have to compare between 22 and 8. 8 is less than 22, so I need to copy this value into a of k. So I'm copying 8 to this position. Now I need to increment the value of j as well as k. J is incremented and k is incremented. Now I need to compare between this numbers 22 and 11. Of course 11 is less than 22, so I will be copying this number into the array A. So I will get 11 over here. Then I need to increment the value of j as well as k. So j is incremented again. So j goes to the next position. So the value of j will be now 4. And the value of k will be now 6. Okay, this while loop will run as long as I is less than 4 and j is less than 4. J has become equal to 4, so it is the exit of this while loop. Now we will be copying the other subarray into the final array. Now we are checking whether the value of I is less than 4. Of course the value of I is 2, which is less than 4. So what we will do is we will copy the content of this left subarray into the final array. So we will get a of k equal to L of k is 6, I is 2. So I will be copying the number 22 into the final array. So I will get 22 over here. At the same time I need to increase the value of k as well as I. So I is incremented. Similarly k is incremented. Now again I am checking whether the value of I is less than 4. Here I is 3, which is less than 4. So I will be copying 31 also into the last position of the final array. So I will get the number 31 over here. Now I will increment the value of I as well as k. Now I is incremented into the next position. Similarly k is also incremented into the next position. So here the value of I is now 4 and k will be 8. So if value of I is equal to 4, it is a violation of this condition. So we will be exiting this while loop. Similarly, we have the value of j equal to 4, which is equal to the value of r, which is 4. So this condition is also false. So we will be exiting this while loop as well. So finally, we got a merged array, which is the result of merging the left subarray as well as the right subarray into a final array. These steps will be happening at every merging stage of the algorithm. Now let's look at the merge sort algorithm. So what we will do is, first we will check what is the length of the original array. If the length of the original array is greater than 1, then we will partition the array into the left subarray as well as the right subarray. Then we will apply the same algorithm on the left subarray as well as the right subarray. Then we will merge the left subarray and the right subarray to get the final array. We will be doing these steps only if the length of the array is greater than 1. If it is equal to 1, then we do not want to sort any further because a single element array is already sorted. A convention that we use to divide an array into left subarray as well as right subarray is this one. If the number of elements in the array is an even number, then we will be dividing the array into two equal halves. Then if it is an odd number, then the first array will contain one extra element compared to the second subarray or the right subarray. So here I have some numbers. In total we have 7 numbers over here. So it is an odd number, so I will be dividing it into 4 and 3 because the convention is the left subarray has one extra element compared to the right subarray. So what we will do is I will be splitting these arrays into two different halves. So this will be the left subarray and this will be the right subarray. Okay, so this comes over here and the other part comes over here. Okay, now we have to sort the left subarray separately and we have to sort the right subarray separately. Once it is done, we have to combine the solution of these two sorting problems. But if you again call the left subarray with the same function, then this step will repeat. That is, we will divide this subarray into two halves, that is a left subarray as well as the right subarray. So these process will be happening on each subarrays again and again. So we have an array 26 and 32. So we will be dividing into 26 first, then 32. So this is 26 and 32. So when you have an array of single element size, then it is already sorted. Now we will start the merge step. So when you merge 26 and 33, you will get 26, 33. Now you have to sort 35 and 29. Now we have to sort 35 and 29. So we will be dividing this one into two arrays of size 1, 35 and 29. Now we will merge 35 and 29 in order to get the solved result of 35 and 29. So this will be 29 and 35. So we have sorted this subarray and we have sorted this subarray. Now we have to combine the result of these. Now we have to combine the result. We are combining 2633 then 2935. So these two has to be merged. So you will get this one. So we have finished sorting the first left subarray. Now we have to carry on the same process to the right subarray. So we will be dividing 19, 12 and 22 into two halves. So this is a array of an odd number size. So I will be dividing it into 2 and 1. So first I will have 19 and 12, then I will have 22. Now in order to sort this one, I will be dividing again this to 19 and 22 separately. Now we will not be able to divide this any further. So we will merge this one. So I will be merging 19 and 12 to get 12 and 19. So this array is already sorted, so I do not have to do anything with 22. Now I need to merge these three elements, so it will be in the order 12, 19 and 22. So we got 12, 19 and 22. Now we have to merge this solution and this solution in order to get the solution for the final problem. If you repeat the step of merging two subarrays, then you will get this as the final sorted order. Okay, so this is how we solve a problem using divide and conquer algorithm. So essentially this is actually happening in the computer's perspective, but in order to get an intuitive idea, we will be explaining it in this way. I hope it is clear. Thank you.